Dear students, this is Kavita BS. In this session, I will explain how to derive the equation for the most probable velocity of gas molecules using Maxwell's law of velocity distribution equation. This topic is related to BSc course Physics subject, paper 3rd, Thermal Physics, Radiation and Optics 1. And this topic is in the chapter Thermal Physics of Unit 1. Let us start the session. The most probable velocity. The most probable velocity of gas molecules can be defined as it is the velocity possessed by the maximum number of gas molecules. Velocity possessed by the maximum number of gas molecules is known as most probable velocity. Also, from the Maxwell's law of velocity distribution equation, we have dN by n is equal to 4 pi a cube e to the power minus b c square into dc. This equation represents Maxwell's law of velocity distribution equation. In this equation, the term dN by n represents the probability of number of gas molecules whose velocity lies between the two values c and c plus dc. Then, if the velocity is most probable velocity, then this term must be a maximum term. Therefore, if you differentiate this equation with respect to c, then this term is maximum, which means constant. Then differential of a constant term or maximum term should be equal to 0. Then if you differentiating this equation with respect to c, we get, since this is the constant term, these two terms are the variables. Then on differentiating this equation, we get 4 pi a cube. First, by considering this term as a constant, then e to the power of minus bc square into 2c plus c square e to the power of minus bc square into minus 2bc, that is equal to 0. Then on further simplification, we get 4 pi a cube into e to the power minus bc square 2c minus 2bc c square e to the power of minus b c square, that is equal to 0. Then in these two terms we have the common term, that is common factor, that is 2c e to the power of minus b c square is a common term. Then by taking this as a common factor, then we get 4 pi a cube into 2c e to the power minus bc square into 1 minus bc square is equal to 0. Here these two terms cannot be equal to 0 since these two terms contains constant values. Hence, in these three terms we should equate this term to 0. Then in the next step we have, that is 1 minus bc square is equal to 0. Then c square is equal to 1 divided by b. If you consider this c square is nothing but most probable velocity of the gas molecules, then instead of c we have to write VMPV, that is most probable velocity. Then finally we get the most probable velocity is equal to square root of 1 by b. On substituting the value of b, that is b is equal to m divided by 2 kt, then we get the most probable velocity is equal to 1.414 into square root of kt by m. This value is value of square root of 2. Then here k represents Boltzmann constant value, T is the absolute temperature of the gas, and m represents mass of each molecule, gas molecule. So This is the expression for most probable velocity of gas molecules. Thank you.